This one video can eliminate overall confusion on CFT. Hello students, let us start. Crystal field theory for octahedral complex where coordination number is 6. In this case, energy of EG orbitals is greater than T2G orbitals. EG orbitals 2, T2G orbitals 3 here. If strength of ligand increases, energy gap between T2G and EG increases. In presence of strong ligand, pairing of electrons occurs in T2G first due to more energy gap. In presence of weak ligand, pairing of electrons in T2G occurs only after half filling EG set. One example given for your reference, D5 in presence of strong ligand, D5 configuration, pairing occurs in T2G itself. Whereas D5 in presence of weak ligand, first 3 electrons here, 2 electrons here. So 1 electron we need to give for each orbital. If it is D6, how we fill? 1 more electron we fill in last T2G level. For tetrahedral complexes, T2G energy is more than EG. So energy sequence like this. All ligands are referred as weak due to less energy gap for tetrahedral complexes. Square planar complex, dx square y square, xy, dz square, dyz, dxz. Energy sequence that remember important. Energy gap in square planar is highest, then octahedral, then tetrahedral. If we compare tetrahedral, octahedral given relation, square planar is 1.3 times of delta O. CFSE calculation for octahedral complex, number of electrons in T2G minus 0.4 delta O, number of electrons in EG into 0.6 delta O plus NP, where N is equal to number of extra electron pairs developed due to influence of ligand, P is pairing energy. CFSE for tetrahedral complex, exactly opposite we wrote. See once how we mentioned here, number of T2G minus 0.4 delta O, here it is 0.4 delta T plus NEG minus 0.6 delta T. Delta greater than P for strong ligands, delta less than P for weak ligand. Whenever it is given like this, consider strong and weak ligands. Whenever there is strong ligand, pairing of electrons occurs, inner D complex is formed, low spin complex is formed. See, whenever more number of unpaired electrons present, see inner D complex meaning here less number of unpaired electrons present. Less number of unpaired electrons. If any more number of unpaired electrons, that is high spin complex. You see, here weak ligand, no pairing, outer D complex, high spin complex is formed. High spin complex meaning more number of unpaired electrons available. So based on this, recent JEE Mains 2026, 23rd January, shift 2. Question here. Observe everyone how they mentioned. First everyone refer the question. They mentioned A, B, C, D, E, different complexes here. They are asking about, choose the correct answer from the given options below. Once everyone refer quickly question here. Very important. So for clue, one important clue here, ligands with donor atoms, fluorine, chlorine, bromine, iodine, oxygen, sulfur are weak. Ligands with donor atoms, nitrogen, phosphorus, carbon are strong. So trick to identify strong and weak ligands. Come to the question now. See in A part, if you see cobalt is in +3 state. Cobalt is in +3 state. So +3 configuration, there is D6. That too here plus strong ligand. NH3 is strong ligand. So whenever there is D6 configuration strong ligand, we know here pairing occurs. So whenever there is pairing of electrons, if there is pairing of electron, what happens? Whenever there is pairing of electron, inner D complex is formed. So inner D orbital is empty and coordination number here is 6 it is. So D2sp3 you will get in this case. Then coming to MnCl6 minus 3. So in MnCl6, Mn is +3. So if Mn is +3, it is D4 configuration. Cl, it is weak field ligand. So weak field ligand, here no pairing of electrons occurs. First you have to fill 1 electron into each. See if no pairing of electron, that too here you observe it. Coordination number is 6 again, either sp3d2 or d2sp3. If it is inner D complex, d2sp3, outer D complex, sp3d2. So here no pairing. Whenever there is no pairing, we know here what happens. Outer D complex is formed, sp3, d2 is formed. Then option C, COF6 minus 3. So COF6 minus 3, CO plus 3, that is cobalt is in +3 state. Configuration is D6, ligand is weak field ligand. So again, no pairing here. So if no pairing, then automatically here what you will get? Here you are going to get outer D complex, sp3, d2. Then Next complex FeF6 minus 3. FeF6 minus 3. So here if I take Fe plus 3, which is D5 configuration plus weak ligand. Plus weak ligand here. So weak ligand here, what happens here? No pairing occurs. So no pairing. Whenever there is no pairing, hybridization should be outer d orbital complex sp3 d2. So remember, whenever there is no pairing, outer d orbital complex is obtained. Next one, NiCN4 minus 2. So NiCN4 minus 2, where Ni is in plus 2 state, configuration is D8, and here ligand is strong ligand. So pairing occurs. So here tetrahedral pairing occurs. Whenever pairing occurs, inner D complex is formed. So inner D complex, what we consider is D2 or DSP2, which is square planar. DSP2 square planar. Remaining all cases like octahedral complexes. Yes, square planar. So by observing all these, what are the curved statements? Here you see. Curved statements, according to given option. Inner D complex D2sp3. First it is correct. So A is correct. Followed by outer D complex sp3d2. It is also correct. B. Then D, outer D complex sp3d2. It is also correct. So A, B, D correct answer. So answer that is 2. 2 is correct answer. Statements A, B, D correct. Okay. Next you see JEE Mains 2026 23rd January shift 2. Total number of unpaired electrons present in central atom. For example, first I am taking here NiCO4. In NiCO4, observe properly here NiCO4, first one. NiCO4, here first of all CO is strong field ligand. So nickel is in 0 state. Strong field ligand. So here NiCO4 coordination number is 4. It may be sp3 or dsp2. S should be vacant. Here what happens? Nickel configuration we know 3d8, 4s2. We need s orbital. So compulsory we need to vacate s here. So s orbital electrons transferred to d. Overall we are getting 3d10 and 4s0. S orbital we should make it empty because we need s orbital either it is sp3 or dsp2. So first of all, strong field ligand. So completely pairing occurs. So hence here 0 unpaired electrons. So 0 unpaired electrons in case of NiCO4. Next one, NiCl4 minus 2. Here nickel is in plus 2 state, whose configuration is 8, plus which ligand given here? It is a weak ligand. Whenever weak ligand is given, pairing occurs. Weak ligand is given, pairing occurs. Ni plus 2 D8. Coordination number how much it is? Coordination number 4. So it is tetrahedral. Because weak ligand, right? It is. Sorry. No pairing, right here. No pairing. So no pairing here meaning more spin, high spin at tetrahedral complex. So D8, if no pairing, 1 electron in each orbital if you fill. So number of unpaired electrons. Number of unpaired electrons is equal to 2 here. Okay. Whenever no pairing, unpaired electrons available. Then platinum in given complex, platinum plus 2 state, which is D8 configuration plus strong field ligand. So here strong field ligand, what happens here? Pairing occurs. So whenever there is pairing, which complex you will get? Here we will get, whenever there is pairing, inner D complex you will get, that is dsp2 you will get, square planar complex. So here unpaired electrons 0. Unpaired electrons 0. Next one, NiCN4 minus 2. Here nickel is in plus 2 state, which is D8 configuration, and then ligand is strong ligand. So here also pairing occurs. No doubt here pairing occurs. So if pairing occurs, so number of unpaired electrons. unpaired electrons is equal to 0 whenever there is pairing. And then fifth one, PtCN4. So here where platinum is +2 state, which is D8 configuration, strong field ligand. So pairing occurs. See, whenever there is pairing, inner D complex is formed, which is square planar is formed. Why? Inner D is here DsP2. For example, coordination number 4 here. So here unpaired electrons is equal to 0. Unpaired electrons is equal to 0. See once how I wrote combination C. First of all, here unpaired electrons 2. Here 0 above, unpaired electrons here 2. Unpaired electrons for this one 0. For below one it is 0. Here also 0. So total unpaired electrons is equal to 2. So here answer is 2. Total unpaired electrons is equal to 2. We need to specify. The key step is every time you identify the metal oxidation state, you find whether it is weak ligand or strong ligand. If it is weak ligand, no pairing. So number of unpaired electrons available. If it is strong ligand, pairing occurs, generally unpaired electrons 0. Strong ligand pairing occurs 0. Strong ligand pairing occurs 0. If weak ligand, no pairing, unpaired electrons available. Okay. So if it is pairing occurs, inner D complex formed. No pairing, outer D complex is formed. I think questions clear to everyone. If any doubt, once again you watch the first part, theory part here, whatever I specified. Thank you. Thank you very much.